All right, welcome to 3 o'clock and hiding in plain sight from blue teams with Henri. Henri's got a background in offensive security, has been working in the area of pen testing and security assessments for about 10 years. During this time, he's been doing a large number of these projects worldwide. One of the founders of Falcon Force, which focuses on combining red and blue knowledge together, kind of purple teaming stuff. He's been working on red team engagements for clients worldwide, challenging environments, strong blue teams, a lot of experience trying to hide in plain sight here. Going to learn from him about that today. The blue team knowledge there helps with the red team. We feed each other, right? So this, the experience he's got bypassing EDRs and blue teams is directly used to build detections and to close gaps that are left by the EDRs. In his spare time, he enjoys low-level development like the rest of us, right? Reverse engineering, and occasionally he gets out of the office and races motorbikes. Okay. Thanks for being here, Henri. Go for it.
Thank you. Hi, everyone. So I think the whole intro was already there. My name is Henri. I do purple teaming at Falcon Force. So I have a background in offensive security mostly. I think for the last 10 years or so, I guess, I've been doing a lot of offensive work. And the last 2.5 years, I've also been inspired to do some blue teaming work as well. I've been doing quite some detection engineering in the last 2.5 years, and trying to use all the red team tricks and all the red team knowledge to build detections for all those tricks. I have a focus on the Microsoft stack, so I work a lot with Sentinel, Defender for Endpoint, Defender for Identity, and all the other Defender for products from Microsoft. I'm a first-time speaker, so it's the first time I'm speaking at least on a public conference. Yeah, so that's about it about me. I think the outline for the talk today, what I mostly will talk about is software which is misbehaving. And I'll come to that in more detail, of course, but I think like 40, 50, 60% of the talk are examples of software which are misbehaving and are behaving like malicious software, basically, while it's legit software, and how you can abuse that as an attacker in your advantage. So that's what the talk is about. So I'll give a short intro on that. We'll discuss how detections are built in general by blue teams, so how they work and why they need filters in their detections. We'll talk about why we want to hide in plain sight, because there are, of course, all these awesome EDR bypasses. So why do you want to hide in the first place if you can just bypass the EDR? I'll touch upon, most of the talk will be about how to hide. What are the different tricks? What are the different techniques to do that? And then I have a very short slide on how to improve the resilience of your detections. So if you're a blue teamer, so I think that this talk is mostly aimed for red team purposes, but I guess there will be some lessons learned as well for blue teamers. So let's get started. I think that the whole idea started with me being in a red team project and thinking about, well, this behavior should never happen in a real environment, in a production environment. I think one example which I very distinctly remember is Office macros which do Win32 API calls. I mean, thinking that never happens in a production environment, right? So it should be super easy to detect any kind of malicious software which is doing a virtual alloc or doing create remote threat from a macro that never happens in production. And then you start looking at it and think, wait, well, it does happen. Okay, that's weird. Well, my bad. And then you look into it a bit more, trying to build an actual detection for those kind of things. And you'll see that, well, it does happen. It happens perhaps quite often, but it's most like 2 or 3 or 5 different applications doing that kind of stuff. So what you do as a detection engineer, what you do as a SOC or as a blue team is take the idea of the attack, filter out all those misbehaving applications. So the SAP application is misbehaving. So I'm going to skip that one from my filter, or put that in my filter and skip on alerting on that. And I have a working detection. And then you do the same trick for a different environment, for a different client, and then you'll see, wait a minute, this is the same software doing the same thing. So this is just generic behavior for this piece of software. And then at some point, well, wait a minute. if this happens, and this is malicious behavior, it's legit. Well, it's legit software acting very malicious. I can also abuse that, and that's where this whole idea came from. I just want to start off with an example, and I'll show a lot of these screenshots here in the presentation. These are the screenshots from Defender for Endpoint. If you're not familiar with the product, and I'll try to go through the queries because I guess not everyone is super familiar with the query language, just to show you what's going on. So the first example of how this all started is, my initial assumption was no process should read LSASS memory, because why would, I don't know, some random process need to read memory from LSASS? That never happens, right? So I wrote a very simple query which looks at all the read process memory API calls, where the target of the read process memory is LSASS. And then I did a count, and you see the number coming up. It's like, it's like 99 million or so. No, I don't even know. It's a lot. I was wondering, why are all these processes reading LSASS? That shouldn't happen, right? Well, it does. It clearly does. So then go to the next idea and just see, okay, who is doing that? So what I'm doing here is just looking at the read process memory API call again, where the target of the read is LSASS. And I'm summarizing by the file name, which is actually reading LSASS memory. So this is like a group by if you're more of a SQL guy. So I'm doing a group by on file name, just getting a count. And then you see that there are like 590 in this environment, at least. So this is an example. Well, this is a production environment from one of our clients. You'll see that 590 unique files are reading LSASS memory. And the count here indicates how often this has happened per file. It's insane. Okay, so how do we detect credential dumps from LSASS then if there are so many files reading it? Well, the next idea was, what if you look at the number of bytes which are being read from the LSASS memory, because the Defender for Endpoint product actually logs how many bytes are being read. So if you do a read process memory and you read a number of bytes, it's actually being logged here. Okay, well let's see how many of these processes actually read a significant amount of memory. Because if you want to do a memory dump of LSASS and get credentials out of it, you need to create a core dump. And that's usually, depends on the system, but that's usually, I don't know, like 10, 15 megabytes at least. And usually it's around 50 to 60. And if it's like a server with a lot of users on it, it will probably be around 100 megabytes or so. So that should stand out, right? So we'll try with 5 first. So what I'm doing here, again, for the non-KQL people, just doing the same query, looking at memory reads from LSASS, and then looking for the total bytes copied, which is more than 5 times 124 times 124, so more than 5 megabytes, basically. Summarize and group by again, and I'll get a bunch of results. And you'll see MS-MPeng is the biggest offender, which makes sense, right? Because MS-MPeng is the Defender for it's the Defender AV agent. So the Windows Defender agent is that process. It makes sense that the AV product is reading process memory. But then there's also WMI. This is the WMI host process. Well, why is WMI reading that? Why is it reading more than 5 megabytes of memory from LSASS? That's a bit weird, but okay, it is what it is. And this is still too much to alert on. If you build a detection rule as a blue team or as a SOC on with this, you'll just be flooded by alerts. This is like, these are like 1600 plus 300 plus 100. All these alerts add up, basically. You don't want to do that. So what if we set the threshold a bit higher? So just randomly removing MS-MPeng, because that's the Defender for the Defender AV product. And this is the first filter already. So you see what's going on here. I'm just ignoring the Defender AV agent, or at least the file name. I'm looking for more than 15 megabytes of memory read. And you still see there's some weird thing called scanner.exe, which is reading more than 15 megabytes of LSASS memory. And there's also this display link hot desk service whatever.exe, which is also reading more than 15 megabytes of LSASS memory. Why does it do that? Well, we don't know. But then again, if I take a step back and look at it from a detection engineering point of view, I do want to have a detection which detects a process reading this amount of memory from LSASS, right? Because I'm trying to detect someone dumping credentials from LSASS. So what I'll probably end up doing, and what I've seen most of the other detection engineers and blue teams doing, is just assume that this is okay, or at least have a look into it, see if it's okay. If it is, just filter it, and put it on a list, on an allow list, and then run the detection, which is great, and that works from a blue teaming perspective, but also introduces an attack vector from a red teaming perspective. And this is the example I started with. And basically what I came up with, I mean, well, this is one specific thing about LSASS, but this kind of weird behavior happens all the time with legit software. So what if I can start building a kind of a database of all the weird behaviors of the different software which are out there, which are legit, but are still misbehaving. And then for each type of technique or tactic, I'll have a list of names of applications which are misbehaving, and I can abuse that whenever I need. So that's basically what this talk is about. Why do we need filters? Because basically, if you've ever worked in a SOC or built detections, you'll see that most of the rules which you build will come up with some kind of false positive, one way or another. False positives are basically inherent to building detections, and you will have to filter them. And there's always this one piece of weird software which just misbehaves and creates these false positives. So there are almost no detections out there in production which don't use any kind of filtering at all. And another example is Office application spawning child processes. 2 or 3 years ago, naive as I was, not having any kind of blue team experience, I was thinking, well, why should any kind of Office application create child processes? That's super suspicious to me. Turns out it's not. Well, it is, but not in all cases. So if you actually try to build a detection for an Office application which spawns a child process, you'll end up with a huge list like the previous ones I showed of all these things happening. So you need to build some kind of filter to manage the false positives. And an example of that is, so if you look at the filters here, this is one of our examples or one of the rules which we actually are using as a detection. So for this rule looks at the rule looks at the number of at Office applications spawning child processes, and then tries to weed out all the false positives or all the legit pieces of software which do that. And you'll see here, for example, Foxit Reader is one of the child processes being spawned. Other Microsoft Office products are being spawned. Microsoft Teams, well, it makes sense because if you click on an Office link, for example, so if you have an Outlook invite which has a Teams call in it, if you click the link, it actually spawns Teams.exe. So that's where it's coming from. But also this one is pretty interesting. The sub GUI for Windows was what I was pretty interested in. That the sub GUI for Windows is actually a child process of an Office application. And I think it's coming from Word. So these things happen constantly. And basically any kind of blue team or any kind of SOC which relies on these kind of detections needs to have those kind of filters in place. And what we can do as red teamers or as attackers is basically abuse those filters. Because everyone assumes nobody knows what I'm filtering, but well, it turns out people do know what you're filtering, and abuse those things and slip into the cracks basically of your detection. You don't even need to bypass the EDR; you can just bypass the rules themselves. We'll also see that this kind of logic also applies to AV itself, and also applies to, in some sense, it applies to the EDR products. But also to attack surface reduction. And we'll come to that in a bit on how you can bypass the attack surface reduction rules in the same way. So then the next question we want to talk about is, why do we want to hide in the first place, right? I mean, if you can easily bypass if you can bypass the EDR, why do you want to do this kind of stuff and do like a guesstimate of what kind of software might be on a machine and then try to imitate that? Because that's what we're doing. And the simple answer to that, I think, is that it's not a replacement for EDR bypass. It's not a replacement for AV bypass, but it's more meant as an extra tool in your toolbox depending on the situation to use it for. So sometimes it's more useful to do EDR bypass. Sometimes it's more useful to just kill the whole EDR. But sometimes it's easier or better or more useful to just imitate an existing application and try to hide basically in the filters instead of trying to just completely disable the EDR. And another place where I use this quite often is for initial access, when you don't have the foothold yet in your environment to do all these kind of advanced stuff like EDR killing and patching UTW or all these tricks which are there to bypass EDRs. But you only are starting off with your initial with your macro. So you have an office an office document with a macro in it. You don't have the privileges yet to do all these kind of tricks. So that's where you can try to imitate some of the weird office behaviors of legit applications, just hoping to fall in the cracks of the filters. And yeah, as I said, there's a lot of security tooling which suffers from the same blind spots. All the security tooling which we've seen so far has similar behavior, filtering false positives. I think the endgame configuration and the endgame EDR configuration leaked a couple of months ago, I think, or someone published it online. And there you could see the exact same behavior where there was some certain parts being filtered by the EDR and not being marked as malicious. Same holds for Defender for Endpoint configuration. The same holds for attack surface reduction. And the same holds for a lot of custom detections built by detection engineers in production SOCs. So again, it's not a replacement of EDR bypass, but it's just more a different technique to accomplish similar things. So how do we do it? This is then the next question. What are the different ways to do it? There are a lot of ways, but what I did for this talk just summarize 5 categories to just show you how bad it gets, basically, how bad real software is, and how you can use that in your advantage in an attack. I first want to talk about Office, mostly for initial access, so all kinds of Office nastiness which you can abuse in your advantage. I want to quickly touch upon process injection, quickly show some things on dumping LSASS. I'll give you some examples on run DLL, how you can abuse run DLL if you want to run your implant in run DLL 32. And I have a miscellaneous topic where just a bunch of different things to show you which didn't fit in any of these categories. It also includes some kind of nice ASR bypasses, which we found based on this research. Just to get started, I think one of the nice tricks in Office, which some of you might or might not be familiar with, is using XLLs and sometimes even WLL files. So you basically send someone an XLL file, which is like an Excel DLL, if you're not familiar with it. You can just double click an XLL file in Windows, and we just happily load it into Excel and then run your code. It's quite widely used attack technique, at least in the red team community, I know. And I just want to do a very quick raise of hands on how often you think this happens in, let's say, in 30 days in an environment with, I think, around 50,000 machines. So let's say you have 50,000 endpoints in an environment. How often are XLL files or WLL files being loaded in that environment in 30 days? So just a quick raise of hands. Who thinks 0 to 100 times? Nobody? 100 to 500 times? Okay, 1, 2, 500 to 1,000? Ish, okay. So most of you think it's 1,000 to 5,000? Yeah, turns out you're more or less correct. So it's like 1,100 times in 30 days. So 1,100 XLL loads are performed in a real life environment. So how are you going to detect a real XLL being? How are you going to distinguish between a legit XLL and a malicious one? So everybody thinks XLLs are super obscure, but it turns out they're not super obscure. It turns out they're being used quite often in production environments. And these are at least the top XLLs being used. And you can use those to hide in plain sight, basically, because those are pretty common. There's one called pipc, but this one is even more widely used. Well, not in this environment, but it's the SAP Business Objects thing. So if you know your client environment is using SAP, then it's pretty likely that they will have the SAP Business Objects thing running. There's actually even one from Microsoft, but don't just ignore that for now. There's some ESS base, which is some kind of product. There is well, this one is very nice. This is from Bloomberg, so there's a nice Bloomberg XLL add-in. So if you know your environment is a financial institution, they're using Bloomberg, then well, this might be a very nice name to masquerade or to use in your attack. And the same for this one. So IBM Cognos is basically, I've seen it. Well, I would say like 80% of our clients, which have a reasonably sized environment, you'll see this one, the IBM Cognos Office Business Intelligence XLL stuff. So if you want to smuggle your XLL, you want to find the right name for your XLL to slip through the cracks, just try the SAP one or try the Cognos one. It will, well, pretty likely it will just go through the cracks, if they even have anything for XLL loads. What do I have next? So one other trick which detection engineers often use is to look at the global prevalence of a file. Global prevalence basically means, at least in the context of Defender for Endpoint, it means how often has Microsoft seen this specific file based on the file hash in all their environments which they are monitoring. So not only in your environment, but in all the Microsoft monitored environments. So one of the tricks which we use and a lot of other detection engineers use is to look at global prevalence. So if something has global prevalence which is less than 200, it means that Microsoft has seen it globally, this file, on less than 200 machines or less than 200 times on a machine. So those are like the unique files. And if you are building your own malware, which has an XLL file, or your own implant, which is an XLL, then you'll have a pretty low global prevalence. But even with a low global prevalence, you still have like 14 unique files which are around. So it's still worth to, well, take a look at what those things are. And even IBM comes up here again with their Cognos Office Business Intelligence stuff. So just imitating those file names, it's well, not guaranteed, but it's very likely to succeed and bypass all the potential detections for XLLs. Some other ideas for Office, if you're interested in that. So there is this in Defender for Endpoint. There is this action type stuff which looks at the ASR rules. ASR rules are the attack surface reduction rules, and they have some specific rules to detect misbehavior of Office applications. So if someone trying to make an Office application misbehave, then these rules cannot trigger. And if these rules trigger either in audit mode or in block mode, you'll get an event in your device events table in Defender for Endpoint. So you can build detections based on that. So looking at the query, so what I do is I look for all the device events which have the action type which contain the word Office. So I'm looking for anything with the action type Office. So I'm doing a quick count based on the action type. So I just want to get a feeling on how many different actions there are. So what I see here is there are 23,000 times there has been an ASR rule triggered, which says Office macro Win32 API calls. So that means that 23,000 times the ASR rule, which is supposed to block Win32 API calls from Office macros, has triggered. So that's pretty interesting from an attacking perspective. Well, same holds for all the other things. So there's the executable Office content. So if you try to drop an executable file on disk, the second ASR rule will trigger. If you try to create a child process from an Office macro, then the third ASR rule will trigger. Well, my assumption always used to be that this is super unique. It never happens in real life, because why would any Office macro in a real application do Win32 API calls? Well, turns out it's heavily used. So we can leverage that for in our advantage in a red team to blend in those existing Win32 API calls. And again, our favorite product shows up, or at least my favorite product, which is SAP. So turns out that well, in this specific case, there has been 940 instances of the SAP, how's it called? SAP script Word 2007.m, a macro-enabled Word document template, which always resides in the user's roaming profile, has triggered the ASR rule for Win32 API calls. So if you want to run a macro and do Win32 API calls and not stand out from the rest, it's worth naming your documents SAP script Word 2007.m. It's pretty likely I will bypass a bunch of filters for a bunch of SOCs and red teams. Same for this one. It's also pretty popular, but slightly less. I didn't know it, but some kind of data collection software. I don't know what it is. I don't know what it does. But turns out it's pretty prevalent, so might be worth looking at it. I blurred out all the other stuff because that was all client specific, and I didn't want to show that here, of course. But these two are pretty interesting. And if you have your actual environment to play with, I would highly recommend everyone just to have a quick look in their own environment to see how often these kind of things happen or what are interesting names in your environment to play around with. We had that. Oh, yeah, we had, of course, the Bloomberg stuff. I forgot to mention that. Or there's the Bloomberg UI.xla, which is another type of Excel format, which does this kind of things. It also is doing all kinds of Win32 API calls. I don't know why, but it does. There is some stuff called AddInSoft, which if you Google for it, it's pretty popular product, which you can imitate to do Office macro stuff. So yeah, there's a bunch of attack surfaces which you can just use to just hide in the filters of the blue teams. Next one is about Office applications creating child processes, and you would guess that, well, by now I guess you know this happens pretty often. I try to run a query where I look at all the process creations, basically. I'm looking for process creations where the parent is either Excel, Word, or PowerPoint, and where the process created is not Excel, Word, PowerPoint, or Outlook. So basically looking for an Office process which spawns a non-Office process. And I try to do a quick summarize just to get a count of the number of times it has happened, grouped by file name and grouped by the parent file name. And I try to do a decount on device name, which basically means how many unique devices did this happen on, and all the command lines. Well, it says the result size exceeds the possibilities of defender for endpoint. It was just so much a defender for endpoint couldn't even handle it. So I had to do it. So this was for 30 days. So I had to get rid of the decount for the number of devices and go back to 7 days instead of 30 days to be able to get some meaningful results out of it. Turns out these are like the top contenders. So Excel spawning SPLWOW64, which I think is the Windows spooler service, if I'm not mistaken. So if you're running an Excel macro and you want to spawn a child process, it's a pretty good idea to call your child process which you're spawning to just call it the SPLWOW64 at Excel. It's likely it won't stand out. Okay, thanks. Oh, this one. So yeah, here you'll see a bunch of other examples of child processes being spawned by Office applications. You'll also see CSC.exe. I'm not sure if you guys are familiar what that is, but that's the C# compiler from Microsoft. If you wonder why this WinWord or Excel is calling the C# compiler, It's because Defender for Endpoint. Defender for Endpoint does some nasty stuff, and it uses on the fly the C# compiler to compile some code from a temp folder. So it's super nasty. It took me like a week to figure out what was going on and why this was happening. But that's why the C# compiler is in there. And then you see Excel spawning. This is, I think, Power BI. You see Word spawning the spool service. MSO Sync, I think, is part of the SharePoint or OneDrive Sync or SharePoint Sync. I'm not even sure. But this stuff happens a lot. So if you're interested in doing child processes from an Office application, just use one of those names, and you might have a fair chance to bypass some of these filters. Here's a bunch more. I think that was like the first, I don't know, like 7, 8, 10. This is like the next 10 or 15 or so if you're interested. Verifold is a very nice one in general. So Verifold is the Windows error reporting application. So every time a process crashes, Verifold kicks in and makes a memory dump of your process. But because Verifold does this, it's a very trusted process by Windows and by a bunch of other AV products. So if you're looking for a nice file to masquerade or a nice file to inject into, Verifold is a very nice candidate to bypass a whole bunch of built-in and custom detections. And then there is the DWWin, I think is DW20 is Dr. Watson, similar to Verifold. There are a bunch of CMD detectors being run. Almost 4,000 times. So even running CMD detector might not be that suspicious if you're coming from Excel. And again, this kind of stuff blew my mind before I was doing any kind of blue teaming and detection work. I always assumed that this stuff was only being done by malware, but apparently it's not. It's super common. Yeah, and there's there's a bunch of stuff. I mean, there's the FLTLDR is the Microsoft filter loader. So it loads some filters. I don't know why it does that. This is also super interesting. So running net use. So apparently people really do that in their macros. And this is not malware, I can guarantee you, because I've looked into all this kind of stuff. But this stuff really happens in real life environments. So don't be afraid to do this kind of stuff. Another one. This is very nice. So apparently there's a very widely used HP printer driver. If you print something from Office application and then your Office applications needs to check the status of the printer or the print job, it uses this one from HP. And this is so widely used that even the ASR rule checking for Office applications being spawned as child processes whitelist specifically this run DLL command with the HP, what is it called? HP MSN version number.dll, monitor print job status. So if you want to do a run DLL from your Office application and you need a good file name, go for this one, HP MSN 120 or 130. Just drop the file on disk, run it, and it's pretty likely you'll bypass a bunch of filters. You'll definitely bypass attack surface reduction with it. And I'll show you the screenshot in a while. ThinkCell, not sure if any consultants here, so a very popular tool with consultants, ThinkCell. It allows you to quickly build some nice nice graphs in PowerPoint and Excel with ThinkCell, so that's also a popular offender in a lot of environments. And this is a dump from the ASR rule. So this is a decompiled ASR rule, and there's this get command line exclusions. So these are the things which the attack surface reduction engine ignores. And here you'll see that it specifically ignores the run DLL32 with the regex for the monitor print job status. Although it has this very specific version number in here, but yeah. So plenty of things which you can do and not stand out. Let's go a bit quicker. So looking at process injection, I've seen a lot of red teams who are super afraid of doing create remote threat because create remote threat stands out, right? They much rather use things like QUse or APC or all the other things because that's way more stealthy, you think. But what we found out is that actually it's the other way around. If you're using these obscure APIs to do process injection, you're standing out way more because nobody's using these obscure APIs to do process injection, while everybody is using create remote threat API to do process injection. So if you do just run this query. And again, this query looks for the device events where the action type contains the word create remote threat, and just does a quick summarize, basically take a count, and it just makes takes a bunch of properties of it. What you'll see is that these are all the create remote threat API calls which are being logged by Defender. So like the first one is the CSRSS.exe, which is I think it's a Windows built-in, or I'm pretty sure it's a Windows built-in thing. Well, you see how often this has happened. You see on how many unique devices it has happened, and you see on how many different files it has acted upon. So basically it means CSRSS injecting into one of those files. And there are 2,400 unique files where CSRSS is injecting into with create remote threat. I'm not talking about the Q user APC or all the other nice tricks to do that. Another one which is very nice to abuse in your red teams is the VMware tools daemon. The VMware tools daemon is a pretty nasty piece of software because it does some nasty stuff, and it makes sense that it does it. But it's great great to hide in the VMware tools daemon if you want to do nasty stuff yourself. You'll see here that the VMware tools daemon has done 18,000 create remote threat calls in 208 unique processes. So it's a pretty nice candidate to imitate if you want to do a create remote threat and don't want to stand out. And again, the same holds for all the other things. I'm not going to go over all of them one by one, but you'll just see it happens super often. And if you, I don't have the slides for the Q user APC API call. The data is in Defender for endpoint though, but you'll see it's significantly less than here. Things stand out way more if you use Q user APC than if you use the create remote threat one. Quickly talking about LSASS dumping. What I did here is looked at the again at the attack surface reduction rule, which is there to find LSASS credential theft, basically. So if someone tries to dump LSASS and ASR is enabled, and in this environment it was, then it logs an event that someone tries to access LSASS memory. This is how often it has happened, and again, it shocked me quite. Yeah, it shocked me that this happened so often. So in 30 days, there have been 4,600 unique files which have triggered this ASR rule, and this is how often they have triggered the ASR rule. So apparently, the WMI process constantly tries to access LSASS memory and read from it. I don't know why, but it happens. Same for setup.exe, which is also pretty nice actually. Setup.exe or msixec.exe just apparently triggers this rule in this specific environment. I also cross-checked these file names with other environments. The numbers are different, but the setup.exe one keeps popping up. It's pretty popular, and the same for msixec. For some reason this happens. So yeah, if you want to dump LSASS, you might consider looking at these file names. Like I can tell you for sure that just using these file names is not enough. So if you just use the file names, which are shown here, you won't bypass attack surface reduction. You won't bypass Defender for endpoint. But you might consider injecting into one of those real processes, and then you might actually bypass attack surface reduction, and you might bypass the Defender for endpoint detections. So quickly looking at RunDLL, I've seen quite some use of RunDLL I think in like the real malware samples, and to some level of degree also in red teams. I think red teams usually try to avoid RunDLL32 because it's pretty well known. But in some cases, it is still used for different kinds of reasons. And I think one of the most legit reasons to still use it is if you're emulating an adversary which is not super advanced. In that case, it makes sense to use RunDLL32 because in real life, the less advanced adversaries are also using RunDLL32. So I was interested in compiling a list of file names which are commonly used in the real environment, and function names which are commonly used in real environments, and to see what happens. So I got a pretty complicated query. It's not very interesting to go into detail, but what I basically do is just use some regular expressions to extract the DLL name and the function name out of the command line. And this is what you get. So if you're interested in using run DLL32 as an attacker, I think your best bet is to use one of those files. So the dovc.int.dll. I think that's the webdov handler, and it calls the function dovsetCookie. I think this is by far the most popular one in literally any environment I've checked this on. And the reason is because this is probably heavily used by SharePoint and by Office 365. So if you have endpoints with Office 365 running on it, and they do the webdov stuff with Office to sync files and to do this automagic word save things and all the new nice features in Office, I think they all use this stuff. That's why it's so prevalent. But again, here you have a list of other ideas of file names to imitate if you're interested in running run DLL32 as a red team. This one is also pretty popular. First, I was a bit struggling. Why is there this weird file name and this weird function running it from even a temp? So there's the C Windows installer temp. So that's the file name of the DLL. It's not even a .dll. And the function is called zzz invoke manage custom action out of proc. It's pretty interesting. And the command line was something with MSI exec. After a bunch of Googling around, I figured out that there's this toolkit called Wix Toolset. A Wix Toolset is like a tool which you can use to create an installer with. And if in your installer you want to actually run some code, which is not during the install process, you can call this invoke managed custom action out of proc function in your Wix tool. And that will basically end up being a run DLL call to this function in your installer. And this one is pretty popular as well. So, I mean, you might consider using these file names for your own benefit if you're doing an attack or want to run DLL32 or run DLL32.exe. And then some MISC stuff, and I'll try to wrap it up because I'm almost through time. There's one interesting thing which still, I'm not sure why it happens, but it does happen very often in a lot of different environments. And what it is that there is this process being created by WMI. So it comes from the WMI PRV-SE, which is a WMI host on the Windows box. It runs PowerShell.exe, and in the command line, it runs the PowerShell, the PS1 file in C Windows CCM system temp. So this KQL query basically tries to extract that and summarize it. And this is what you'll get. So WMI is running this PowerShell line. So it runs PowerShell.exe with, well, dash no logo, no interactive, and all the other flags. And I replaced the random GUID here just to get the proper count. But this is super popular. So if you're interested in doing lateral movement using WMI and you want to hide in the filters of the blue teams, just do WMI, go for PowerShell.exe as your executable with these exact command lines and put something in the CCM folder. And you'll probably slip through the cracks because there's nobody can alert on these things because these things happen so often in a real environment. It's impossible to alert on it. So if someone has a custom detection for lateral movement through WMI, this will definitely be in their filter. And these are the actual commands being run from the PowerShell scripts, which are com-host.exe, makes sense, console host, robocopy, dism host, blah, 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 a whole bunch of stuff. But that's what comes after you're running your PowerShell. Another one, another trick which is at least pretty interesting to me is, I want to do it again, a raise of hands. How often is there a new item created, a new file created in a startup folder in an environment? And just to give a feeling before I do a raise of hands, I've looked at 30 days in an environment with 60K endpoints. So anyone want to take a guess how often a new folder is a new file is being created in the startup folder in the start menu? It's like the most low-tech persistence which exists on Windows, I guess. 0 to 100 times. Any hands? Good. 100 to 500 times? Nobody? 500 to 1,000? Okay. 3-4 people I think I saw. 1,000 to 5,000. Well, it says plus, but Yeah, 1, 2, 3. Oh, well, 5,000 plus. Ah, good. The actual number is 95,000. So if you think that creating an item in the startup menu is not stealthy, well, think again, because like 95,000 times happening in an environment with 60K endpoints. So it's pretty common. And by far the biggest offender is this thing. Office is Office really, really, really wants you to have the send to OneNote application started up on startup, and it will put it there every time you start up your machine. So if I look for run a query and look specifically for the file name contains OneNote, because it's in a bunch of languages here, it's localized, you'll see it happens 35,000 times. So if you are interested in persistence using the startup folder in your start menu, go for the file name send to OneNote.lnk. It will definitely not stand out because it happens all the time. Some nice ASR bypass. So it's bit related, not too much. But what we found, I forgot the name of the guy, but someone managed to find a way to decompile to extract and decompile the ASR rules. He put a bunch of those on GitHub, but not everything. What we did is we continued his research and we just decompiled everything and got all the ASR rules out. I found quite some interesting things. So, there's an ASR rule for blocking Adobe from creating child processes. And this is the filter inside the ASR rule. It's a Lua script. There's the function called get path exclusions. And these are all the exclusions. So if you're creating, I don't know, this specific one, local app data, send browser application / chrome.exe, it will just bypass this specific ASR rule. This one is for dumping LSASS, and this is, I'm sure you guys are interested in this one. If your application is called where-fault-secure.exe or called mrt.exe with a specific path, you will bypass the ASR rule. The ASR rule will not trigger on if the executable you're running is one of these. And the interesting ones, which at least stand out to me, is also the Splunk one. So I'm not sure, but for some reason the Splunk daemon is also on the list. There's a very funnily named a file name with a very funny name called trolleyexpress.exe. So I don't know why, but if your file is called trolleyexpress.exe and it's in this Windows temp folder, it will not trigger the ASR rule. So there you go. So basically, the point I'm trying to make is that the same type of logic also applies to just the built-in Microsoft products, being attack surface reduction, and the same for the Defender for Endpoint. So we got the Defender for Endpoint config out at some point, and here you see the same thing happening. So this is part of the Defender for Endpoint config, which is logging PowerShell commandlets. So basically doing PowerShell script block logging, more or less. And what you'll see here is that it has a filter which says, let me look at it. It says the operator is not. So it filters out everything which is not coming from the process sense.ir.exe and has this CI, code integrity signing level 12. So if you make sure that your binary has the original file name of sense.ir.exe, which is fairly easy to do, and you have the right signing level, which is 12. I'm not sure what it exactly means, but I'm sure you can get it signed on that level. You'll just bypass this whole EDR collection rule. So yeah, it's pretty useful to have those things as well. And then one final slide on how to improve your detections if you're a blue teamer and listening on this one. I think it's pretty hard. There's no real way to avoid it as far as I know or could think of. The only thing you can do is just try to minimize the impact or the likelihood of abuse. And to do that, you can use full paths or regular expressions for full paths instead of just using file names, because file names are super easy to copy paste. Having a full path in there, especially if the path is inside a protected folder, makes it already a bit harder. Always assume that the attacker does know what your filters are. Don't fall into the trap thinking, well, but no attacker knows what filters I'm using, so he cannot bypass it. Just assume he knows it, and he might or might not know it, but at least assume the worst. build separate detections to detect these kind of masquerading. If you know that you have filters in place which are bypassable, that's okay. But at least try to build a rule on top of it which tries to detect someone masquerading these filters to bypass your detection rules. Be redundant in your detections where needed and possible. So sometimes there are 2, 3, 4, 5, or 10 ways to detect something. Try to at least have 2 or 3 ways to detect a certain attack type instead of just having one rule and just be done with it, because that one rule might be able to someone might be able to bypass that one detection rule. But if you have 2 or 3 of those, then it might be already significantly harder to bypass if you detect it in 2 or 3 different ways. And the final one is to maintain your filters. What I often see happening is that filters are being added all the time to detection. So there's new false positive popping up after a month or 2 months in production. So someone adds a new filter to the list of existing filters, but nobody ever removes filters from detection rules. And try to think about it as well. Try to see, like, I don't know, like once every 6 months, go through all your filters and see if the filters are still needed, and if there are still false positives being generated if you remove the filter. And if it's not, just get rid of it. And the final one is don't overdo it, because I mean, if you start filtering on file hash names, you get like insanely complex detections which are not maintainable anymore. So try to find a kind of balance between, I guess, maintainability and resilience. Because if you try to make everything watertight, it will just be impossible to maintain. And that's all I had. Thanks for listening. Any questions?
One question online from vhost. Vhost is asking, do you have a top 5 list of common lull bins that adversaries use, like things that the blue team could be hunting for?
No, I don't have a top 5 of common lull bins. But I personally try to avoid using lull bins because they stand out. I mean, lull bins are pretty nice, but if you start using, I don't know, like cert util to or you start using bits transfer, how this tool is called, the bits admin, to download files, it stands out like I mean, it's nice that the function is there, but nobody uses it in real life. And if it's not being used in real life, it stands out as a huge red flag. So in general, I try to avoid using lull bins and yeah, try to blend in with existing stuff and just try to look at what's happening in real life and try to imitate that instead of using lull bins. That answers the question.
Any questions in the room?
Yeah, have you seen any of this neutered with the WDAC or with application?
If it's being blocked, you mean by a? I haven't looked into that, to be honest. I don't really know. I don't know. I don't know. Yep. No, I have not. I have not. So we looked at the ASR rules, but it's pretty complicated because you have to extract them, export them, decompile them before you get the kind of broken Lua code out of it. But I don't think it will be, well, I haven't tried it, but I'm pretty sure it will be pretty hard to just go back the whole chain because I think these things are also signed. So I'm not sure you can easily modify those. But yeah, there's a ton of gold to be gotten from just looking at the decompiled ASR code. I mean, the code's just on GitHub, so you can just pull the code off GitHub and just decompile it yourself and look at all the nice stuff which is in there for all the teamers here. Yeah. I'll share it with you after the talk. I don't have it. I don't have it ready. I'll share it with you after the talk. I have it somewhere. Yeah. No, I have to keep that private. Yeah, I can't share all the analytics. I also don't want to share all this stuff in a blog post because it's, yeah, I'm a bit afraid it will be abused big time by a lot of people. So I just want to share it here and everyone here can know, but I don't want to put it on the internet so everyone can just start playing around with it and doing this stuff with malicious intent. Other questions? Cool. Thanks, everyone.